Well, I've got a few questions. Shall I start off with one, actually? I'm really glad we ended quite positively, because it is it's such a potentially gloomy, huge subject. So perhaps I can ask, with all this information we're learning about better attribution, how is that going to help us communicate the problem that we're facing? I don't know who wants to kick off on that.
Well, from my own personal point of view, we have a big challenge communicating this sort of quite gloomy message in relation to climate change. And obviously there are people who are sort of question the science and question the evidence, and that's completely reasonable. And one of the things is people often talk about weather, because that's what matters to us, because that's what we experience. And whether or not we can sort of attribute these extreme weather events to things like climate change. And so, because we're always getting questioned for the evidence, if you're trying to put forward a gloomy message such as we are, it certainly helps from my point of view to look at the attribution research and to be able to say, we're getting better at being able to link events to climate change. So from a kind of practitioner point of view, as a researcher working on the other side of it, it's incredibly helpful to have this new research going on.
Peter?
Follow up with yes, that's right, I agree with that. I think people rightly want to know where we are now, whether what they're seeing outside their window and that's affecting them is related to climate change, and how it's related, and how climate risks are changing. And as I said in my presentation, that will make people, with better scientific information and better ways of communicating that, hopefully will make people make better decisions and therefore be more resilient to what we are going to have to face. And I think in terms of looking ahead, it can really help us improve our predictions. So, for example, at the Met Office Hadley Centre, we are developing this really difficult science of seasonal prediction. Now, it's really hard. There are some parts of the world, and it's unfortunately not really in the UK so much, but there are some parts of the world where there is potentially quite a bit of skill there, although we are beginning to see a little bit of skill in the winter for the UK too. But nevertheless, as we do this science, we'll be able to provide better forecasts for people and be able to help people cope better with extreme weather.
Yeah, well, I think from a pure communication point of view, it is quite a powerful message if you can say, this extreme event has been made 200% more likely due to anthropogenic climate change. And this kind of event costs actually an awful lot of money, the losses and the damages. And so for people who think, oh, we can't do anything about climate change because it will destroy our economic growth, to point out actually this is climate change and it's happening now and it costs now money, is a powerful message to underpin the more gloomier ones that Alice has to say.
Mm-hmm. Yeah, grounding it in the here and now. Yeah. Okay, so let's open it up. Right, there you go, right there, here's one. I think there's a microphone coming around if you just for that.
Okay, hello, my name's Ian Simpson. I run a website called look-up.org.uk, and I'm investigating exposing current climate engineering. I'd like to ask the panel why the global warming movement was rebranded climate change, and whether they agree that it's because even the IPCC had to admit there's been no warming for 18 years, and how exactly the climate is changing. I've exposed on my website evidence of why CO2 levels have gone up by 20 to 30 parts per million over the last 20 years, and that graph confirmed it. And yet there's been no warming. So, can we actually really believe the link between CO2 and warming, and and also the NOAA?
Okay, let's just take that there. Okay, so the pause in warming. All right.
Let me start with that question. Well, there is warming. It is just that in the last 10 years, there is no, and the annual global mean temperature rise is not as it was before. However, when you, for example, look at the temperatures over land, they continue to increase quite a lot. And when you also look at what we know about the natural variability in the climate system and what we can model with our climate models, there are phases where the natural variability goes tends towards cooler phenomena, and then there are other phases where the natural variability amplifies the warming. So there is no climate change. The warming has not stopped.
Just to follow on from that, what you really need to do to look at whether warming is continuing or not is look at the global energy of the climate system, because basically the greenhouse effect, of course, has been established for centuries, and what we're seeing is the enhanced greenhouse effect. So what you need to do is to see whether is more energy being trapped in the climate system. That means most of the energy is actually going into the ocean. 93% of that increased energy is going into the ocean. If you do that, you see over the last 10, 15 years a very clear increase, pretty much a monotonic increase of the increased energy trapped in the climate system due to this enhanced greenhouse effect.
Can I just say that that theory wasn't proposed until the IPCC had to admit 18 years of no warming?
Is that true? I don't know.
That's a rather strange way of putting it. The IPCC, as I was involved as a lead author, we looked at rather carefully at we have what's called a box, which means in IPCC parlance we looked in quite some detail at some of the details of this variability, as Freddie has said. And indeed, since the IPCC, there's been even more literature that's borne out what we said then, the report that was released in the autumn of last year, basically which is saying that there's variability. It's to do with what's happening in the ocean. It's to do with we're seeing this, one of the aspects of this, you may have heard of the El Niño Southern Oscillation. We go between El Niños and La Niñas. And indeed, there's literature that shows that if you take account of that, then again, it supports this earlier remark I made that the overall energy in the climate system has been increasing. So that that evidence is really, really robust, and we could go on in great detail about that, but there's really strong evidence that climate is warming as a result of those enhanced greenhouse gases in the atmosphere.
Okay, hang on. Let's let someone else have a turn now. This gentleman here, sorry. Okay, thanks for that.
Is Australia going to be habitable in 2050?
Sorry, we didn't.
Is Australia going to be habitable in 2050?
Well, there are some real big challenges in Australia, and Australia already, in its natural climate, has already some challenges. So, we've got to acknowledge that, and it's a country that has fires and so on. But it's being challenged really severely, not just because of the heat, but because of the rainfall, the systematic changes in rainfall patterns in the southwest of the country, for example. And that, again, is well understood in terms of large-scale global circulation changes and climate change. So it's a real tough challenge for the Australian people to deal with what in many places already a harsh climate becoming harsher.
Okay, yeah, this one here.
Deciding whether it's related to climate change and our emissions, when you decide that, would it be presented on the news along with the weather, or would it take a while for the results to come back? How quickly would they be presented? So how would it be shown to the population?
So was the question how fast we can make these attribution statements?
Yeah, are we going to get it in the weather, evening weather? Is it going to be?
That is actually the aim. So both our research group. So currently, what we do is we use the observed sea surface temperatures to force our models. So we have to do it after the event happened. But we have two projects which, and Peter has talked a bit about that. We are aiming to do operational attribution, so that we want to do this kind of studies while the event is still unfolding, and we will be able to do that in using seasonal forecast sea surface temperatures to drive our models instead of observed sea surface temperatures, so that we will be able in much shorter time to actually, the goal will be to be able to present this kind of information when the world is actually asking us the question and not a year later.
Yeah, that'd be amazing if it's on the evening news. Any up there? Yep, there's a gentleman there.
Hi there. This question might be more towards Alice. I study at CAT, which is the Centre for Alternative Technology in Wales. I've spent 2 years learning, and I'm more dejected and cynical than ever. Are we really going to actually change given this strive for economic growth and the greed we have as humans? Are we ever going to curtail those for the benefit of our future generations? Is that a realistic aim, or are we just going to kill ourselves off?
I couldn't keep doing this job if I didn't hope and think that actually we could actually sort of turn this around. One of the things that I've found quite uplifting recently is that this debate about economic growth, which has obviously happened before, you know, there's sort of a prosperity without growth type arguments back in the 1970s. There's quite a lot of energy in economics departments in universities at the moment, coming from the students, asking to have economics taught in a different way, to be thinking more about ecological economics, and sort of putting aside, trying to put aside some of the more conventional theories that effectively, I mean, underpin some of our misunderstanding of why we've had an economic recession and so on. So there's, you know, economics in general is a field, it's not my field, but it's a field where there's a big debate going on, and there was a conference that was organised this year looking at the steady state economy, so looking at whether, you know, there actually can be different models out there that can continue with, you know, good well-being and so on, but actually have a steady state in terms of economic growth. And they expected 500 people to go to this conference, an academic conference, and 3,000 people registered, and they had to expand the event. So there is a big debate going on, and I think that debate just needs to keep going. And maybe that's where you know, some of the solutions and some of the hope lies. I think technically and physically we can do it, but whether or not we have the will, I don't know.
Okay, yep, one question here.
Thank you. Alice, I'm afraid this is to you again. I think we're actually far too gloomy. What I despair about is politicians, their ability to understand and to get things done. And I think we focus far too much on the supply side and not the demand side. For example, 25% of the energy used in the UK is for lighting. LED lighting uses 60% less. That's 15% of the power we use in lighting alone. Also things like...
sorry, are we getting to a question?
Yeah, sorry, we are. So
okay.
Things like solar panels are widespread, but there's not a lot of solar thermal, which produces tremendous heat, actually. And I just wonder, from your point of view, should we not be focusing more on sorting the demand side rather than the supply side? And that means we don't need to think about stopping economic growth.
I do think we should focus on the demand side, which was one of my main points that I was trying to get across, because the supply side takes a long time, there's lots of big infrastructure. I also think there's a lot we can do. So we talk about energy, and we often mean electricity, but actually there's also transport and heat, which are huge contributions to CO2 emissions. And there's a huge amount more we could do on the demand side in transport, in road transport. We already have cars, even performance vehicles, that can have 85 grams of CO2 per kilometre. But that isn't a standard that is pushing the industry, where our standards are very lenient in terms of car transport, and yet we have the technology to do it. So I definitely agree we need to focus on the demand side, but some of that demand side needs to be behavioural change, and that's where this challenge comes with the growth aspect.
Great, okay. Yeah, there's a question just down here. So I'll get to the back in a minute. I'm kind of blinded. Yeah.
This is for Alice as well. How long do you anticipate we can carry on living the way that we do before the changes that would have to happen mean the impacts are too great?
How long have we got? Is that the question, basically?
I mean, I think that's more of a question for people who work on the impact side. I mean, we've been saying for quite some time that we need to do something. Well, we were saying in 2006 that based on carbon budgets, we really needed to do something in 5 to 10 years in terms of really starting to reduce emissions. What's actually happened in the UK is that due to the recession, our emissions, partly due to the recession, our emissions have started to slow down. But as I said, they've started to increase again. I think we only have a few years, particularly in the richer countries, to actually avoid the 2 degrees. But then that's also, I should say that, you know, 2 degrees, it's not a hard and fast, I mean, it's a target in terms of policy terms, but we still can avoid lots of climate change by doing a lot. Whether or not we will manage to avoid 2 degrees is another matter.
And I think, how long have you got from the impact side? That really depends on where you live. I think in the UK, or in the US, or in the developed world, we can deal with a lot of the impacts. But if you are currently living in Northern Africa, where there is already water scarcity, then you will probably say, well, it's now, it's there. This place becomes uninhabitable. So.
Okay, let's have a look at someone at the back there. There's a gentleman there.
Thanks. Can I ask 2 questions?
Let's see.
I'll ask the first one. This is to Frederica. I was wondering, you talk about you have the 2 different models, and then you run the simulations to see how likely a particular wild weather event is. I was wondering specifically what the differences are in the models. So when you say one model is with climate change, specifically how is that different to the other model? And my other question, which is a general one, it all sounds a bit gloomy, but 4 degrees must be avoided at all costs. So I was wondering if, as a plan B, there's any research into not avoiding it, but tackling it. So I don't know, like bioengineering something to break apart. I know it sounds wacky, but we've done it with mosquitoes and yellow fever and goats and spider silk.
Okay.
So
okay.
Is there any research like that?
Okay, so the difference between the 2 models, and is there a plan B?
So the difference between the 2 models is, well, it depends on how you frame the attribution question. But normally we ask how much has the probability of an event occurring changed due to our CO2 emissions. So the difference between the world with climate change and the world without climate change are the greenhouse gas emissions in the atmosphere. So we keep everything else the same. So the volcanoes go off as they go off in the real world, and the solar forcing is exactly the same. But the greenhouse gas forcing in the world without climate change is on pre-industrial levels. So that is the main difference.
And plan B?
I'll have a go at plan B, but just to preface that with a remark about, there's a big difference between a 2-degree world and a 4-degree world, and the climate model projections clearly show that potentially, subject to everything Alice talked about, we can avoid that 4-degree world. I'm going to go to China in a couple of weeks, and because we're doing some work scientifically with Chinese scientists, and I think that's quite interesting, because often people say, well, what can we do if China doesn't do something? What I can say about China from my own particular perception is that they have some big challenges in terms of what that will mean in terms of climate change for China, which they are recognizing. There is big threats around drought, around their agriculture, around their crops, and they're really taking it quite seriously. Now, there's another thing to translate that into emission reductions, and that's a whole other debate around growth and so on. The plan B, which I think there is one plan B at least, which I think has some difficulties with it, is around geoengineering. You may have heard about putting mirrors in space, or creating pseudo-volcanoes that put dust way up into the atmosphere. And while that is actually economically quite feasible, I went to a presentation just a couple of weeks ago, it wouldn't actually cost that much to put dust up into the atmosphere to create a shield to basically counteract this radiative forcing, this that we've got that's warming up the planet. It would, however, cause some potentially pretty severe consequences on rainfall patterns, for example. So that plan B, which is being talked about, that particular plan B, needs some pretty careful thought. So I think it is worth doing a bit of science on that, but that's not to say that the scientists who are interested in that are supporting it. It's rather that we should probably think about it rather
worst case
carefully.
scenario type situations. Okay, let's just have a look up there. Yeah, there's a gentleman there.
Yeah, I've got a question in relation to the extreme weather events currently being connected with climate change. And my question is, do you definitely think they all are connected with just a kind of inadvertent climate change that you've discussed? I'm thinking particularly of a couple of programs such as HARP, the High Frequency Active Auroral Research Program, which is a $290 million US government program designed to affect the ionosphere. And some people are saying that is responsible for some of the earthquakes, and Hugo Chavez, a Venezuelan governor, actually said that was responsible for the 2010 earthquake. Or take the second example, the chemtrails, where you've got barium, strontium, aluminium poured into the atmosphere in levels which are actually thought to be kind of toxic. And
so, okay, so the question is, how sure can we be about which extreme events can be attributed to climate change? That's basically what it's saying.
More than that, are there any... Have you on the panel actually done any research into kind of these alternatives of weaponization of weather, or have you encountered any research which has convinced you that there might be some of that going on?
Okay.
No.
Yeah, I think that's quite, get rid of that one quite quickly.
No, and why do I say that? Because we have...
The Met Office runs a series of NEXRAD stations all over the UK.
We have...
This guy works at the Met Office.
That's the question. So we have, we have very clear... the simplest explanation actually turns out to be the true one, right? So we're enhancing the greenhouse effect. It's increasing temperatures. If you increase mean temperatures, I showed in that diagram, the chance of having extreme temperatures increase. There's more moisture in the atmosphere. That's been understood for many, many years. That means that there's a potential for heavier rainfall events. What we are not saying is that every single extreme weather event is due to human-induced climate change, because we have always had extreme, as Freddie has shown with the flooding example in Oxford, we've always had extreme weather. And part of the whole point of this science that we're trying to do is trying to tease out how climate variability, natural variations, interact with this longer-term trend towards a warming world. And we think that by doing that, we'll understand some events are getting less frequent. So in some risks are getting smaller.
Okay, we've only got time for a couple more, so if you can make them brief, please. Yep, go ahead.
This is not entirely directly related, but you'll get this. We've been watching what's been happening with the Ebola crisis, and we've been seeing Ebola deniers. We've been seeing people saying in Liberia, there is no Ebola. And at the same time, we've been seeing people die, and now dying in their thousands. Personally, I think the climate deniers are very similar. And the problem is that people do not want bad news. How can the communication of what you have to put across, which is we really have to deal with this problem, how can that communication fight against the natural feeling on people's part that bad news cannot be the case? And I'm sorry, but I see these climate deniers in the same way as I see these poor people in Liberia who are denying that they may be dying at any moment.
Well, we kind of touched on how to fight against the gloom, really. So let's, I take your point, but I think Alice has pretty much gone there. So let's just have one more to wrap it up. I saw you earlier, the gentleman over there. Oh, sorry.
Hi, it's really quite quick. The global insurance industry is surely one of your greatest allies, given that they're exposed to so much of the risk, and they have a fairly central position, especially within London, but also within the global financial system. Are they not one of your most obvious allies in terms of influencing policymakers, economists, and everyone else? And do you talk to them? Do you work with them? And if not, should you?
Okay, insurance, very quickly, please.
That is easy to answer. Yes, we do work with them. Yes, we do talk to them. So they are obviously very interested in the attribution questions for their own interest, and they are also very, very helpful because they have a lot of experience in modeling certain types of risks and certain types of impacts. So we talk to them a lot, and we learn actually from each other.
And they care about getting it right? They really care about these risks. And at the deep scientific underpinning level of their industry, they really want to know that.
Okay, great. Look, we could go on, but we have got to get out of here at 8, and it's 8 o'clock now. So look, it just remains to me to say thanks very much to our three guests. And thanks everyone for coming. You can carry on the debate on using the hashtag NSLive. Lots of people will be chatting about it, so please carry on there. And there's some forms on your seats, so a questionnaire. Please fill that in. It's really important for us for shaping future events for New Scientists, and you can be entered into a free draw for a prize. So once again, thanks very much everyone for coming, and thanks again to our speakers.